All right, here we are going to use this graph to list the x-intercepts and the factors of the polynomial function y equals f of x and solve the corresponding polynomial equation. So this is pretty much the same problem that we did earlier. We're also going to find extreme values. So we did this for quadratic functions. Now I want to look at this for this quartic polynomial. And this is y equals f of x. So the x-intercepts are the points at which the function crosses the x-axis. So here at -2, 0, that's the first point. Here at the origin. And then here we are at 1, 0. So the factors then that correspond to those intercepts, notice that this touches the x-axis and then turns back. That means you have an even multiplicity. The multiplicity can't be 4 because we've got these two factors, and then the degree would be, so we're going to have, this is a quartic polynomial. The factors are going to be x plus 2, corresponding to -2, the 0, -2. The factor for this is going to have at least a multiplicity, x squared, even multiplicity, and here it's going to be x plus, or I'm sorry, x minus 1. The solutions to the equation f of x equals 0 are the zeros, which are -2, 0, and 1. Those are the x values of your x-intercepts. Those are the zeros. And then it asks where we have extreme values. So here you can see this is the absolute minimum value, and this is a local minimum, and this is a local maximum, and it has no absolute maximum. So because the graph goes up forever. So it has no, so we'll just say none. And the local maximum occurs at the origin. So the y value is your maximum value, and the x value is where it occurs. So in this case, it's 0 at 0. And then the minimum, the local minimum, we have a local minimum here at -3 and a local minimum value here. And that's hard to see where that is. So this is -1 here, and I'm just going to say, we can't really judge. I'm just going to say approximately minus, it looks like 3/8. Let's just say that. I didn't pick a very good point there. So the local minimum is -3/8, and I'll just put approximately -3/8 at, and again, that's approximately 3/4, let's say. And then we have a local minimum here, which is approximately -2 and 7, let's say 3/4. So -2 and 3/4. And that occurs at approximately -1.5. Okay, so the absolute minimum occurs at this point, and the x value is the location of the y value minimum. So the y always refers to your extreme value, and the x always refers to the location of that. Okay. I didn't pick a very good example here just because I had to use approximate values. That would not happen on a test. So sorry about that confusion there, making it difficult. Didn't mean to do that. And then here we have, again, another quadratic. And the x-intercepts are -2 and 5. So -2, 0, and 5, 0. That means the factors are x plus 2 and x minus 5. And the solutions to the equation f of x equals 0 are x equals -2 and 5. The local maximum, there is none because the function goes up forever. The local minimum and the absolute minimum would be at the vertex. And that is at 1, looks like 1, -11. So we have a local and an absolute minimum of -11 occurring at 1. All right. Here it says state the end behavior of the graphs of the following functions. So what you need to remember for end behavior is that you've got the degree is even. So let's say degree is even or degree is odd. And then the leading coefficient is going to be positive or it's going to be negative. Okay, so you're looking at those things, the degree and the leading coefficient. If the degree is even, your end, the end behavior of the graph is going to be identical. If the degree is odd, the end behavior is going to be opposite. So for even degree, if it's positive, they're both going to go up, and if it's negative, they're both going to go down. And the odd degree means they're going to be opposite. So if it's positive, it's going to be down on the left and up on the right. And if it's negative, it's going to be up on the left and down on the right. So here, even degree and even degree. So here, because the leading coefficient is negative, they're both going to go down. And here, the leading coefficient is positive, so they're both going to go up. Okay. Here we have odd degree, negative leading coefficient. So we're going to have it go up on the left and down on the right. And that's how you analyze end behavior.